Okay, here in section 3.5, we're going to talk about how to solve exponential equations and then work through application problems that involve exponential equations. And so here I've just listed the steps for solving an exponential equation. The good news about this is that it is pretty much the same every single time. You're going to follow these steps right in order. So you're going to isolate the exponential expression, meaning get it by itself. The exponential expression is just the expression that has the variable in the exponent. Take the natural log of both sides, then that's going to allow you to apply either the power rule or the identity that we learned back in section 3.4, and then finally you're going to solve for x. Okay, so on example A, we have 6 to the x power is equal to 42, and so just following my step-by-step process, the first thing I recognize is that the exponential expression is right here, 6 to the x, and it is already isolated, meaning it is already by itself. And so I'm ready to move on to step 2, which is to take the natural log of both sides of this equation. And when I do that, what it allows me to do then is to apply the power rule. And so that means that my exponent can come into the front of the logarithm, which is going to make this say x times the natural log of 6, which is equal to the natural log of 42. And now to solve for x, we're just going to divide both sides by natural log of 6. And so this will be x is equal to the natural log of 42 divided by the natural log of 6. And punching that into your calculator, rounding to 3 decimal places, is going to give you 2.086. Okay, here on example B, my exponential expression is right here, 5 to the x plus 1. And so I've got to, first of all, get rid of that minus 3 by adding 3 to both sides of the equation. So this is going to give me 5 to the x plus 1 is equal to 24. Okay, now that I've done that, the exponential expression is isolated. I'm going to take the natural log of both sides. So natural log of 5 to the x plus 1 is equal to the natural log of 24. Once I've done that, I can now move my exponent into the front of the natural log of 5. And so this is going to be x plus 1 times the natural log of 5 is equal to the natural log of 24. And now I want to try to get x by itself. So the first thing we want to do there is then divide by the natural log of 5. And so that's going to give me x plus 1 is equal to the natural log of 24 divided by the natural log of 5. And I'm leaving that as an exact expression right now. You are more than welcome to go ahead and type that into the calculator if you want to. But if you want to leave it as an exact expression, that's perfectly fine as well. And so from there, we're ready to get x by itself by subtracting 1. So natural log of 24 divided by the natural log of 5, and then subtract 1, and plugging that into your calculator and rounding to 3 decimals should give you 0.975. So if you're plugging into your calculator, you're not getting that answer, please feel free to reach out to me and let me know. I'll be happy to walk you through how to do that. And like I said, if you wanted to come back over here and you wanted to just go ahead and type this into the calculator, you would get 1.975 approximately, and then just subtract 1 in your calculator from that value. Okay, here on example C, my exponential expression is right here, e to the 3x. And so I'm going to go ahead and take the natural log of both sides since that is already isolated. And so I'm going to have natural log of e to the 3x is equal to natural log of 8. Now, I remember from the previous notes that natural log and e are inverses of one another. And so therefore, this is going to cancel out. It's going to leave me on the left-hand side with 3x is equal to the natural log of 8. And so therefore, to get x by itself, we're just going to divide both sides by 3. And if we go ahead and round that in our calculator to 3 decimals, we're going to get 693 for our answer. Okay, letter D is somewhat similar here, except our exponential expression is not isolated. That exponential expression would be right here, this e to the 2x, and so I've got to get that isolated first. First thing is we want to move this minus 1 to the other side, so that's going to become 3e to the 2x is equal to 13, and I'm still not quite isolated because of that 3. Again, here's my exponential expression, and so to get rid of that 3, we just need to divide by 3 on both sides, and that's going to get that exponential expression isolated. I'm just going to leave that as a fraction. Okay, we're now ready to take the natural log of both sides, so ln of e to the 2x is equal to ln of 13 divided by 3. That's going to cause the ln and the e to cancel out, just like it did on the previous problem. And so 2x is going to equal to the natural log of 13 divided by 3. And so to get x by itself, we're just going to divide by 2. So this will be natural log of 13 divided by 3, and then all divided by 2. And when you put that into your calculator and round to 3 decimal places, I'm going to put 0.733 as my answer. Okay, letter E, you might notice that this equation has exponential expressions on both sides of the equation, and so that's going to ramp up the difficulty just a little bit, but for the most part, the philosophy here is going to stay the same. There's just going to be a little bit more algebra involved. And so, first of all, both exponential expressions are isolated, so I'm ready to just jump straight into step 2, which is to take the natural log of both sides. And so I will have the following. And so now what that allows me to do is to move my exponents into the front. And so this is going to be 2x plus 3 times the natural log of 4 is equal to x times the natural log of 5. Now, if I'm going to solve for x, what I want then is all of the terms that have x on the left-hand side of the equation and every term that does not have x to be on the right-hand side of the equation. And so to start that process, I'm going to distribute this natural log of 4 into this parentheses. And so you're going to see some things that you're maybe not used to seeing. So for example, 2x natural log of 4, sometimes you might see that written as 2 natural log of 4x. I'm not usually a huge fan of that because there's some ambiguity there, unless you go ahead and put some parentheses on that 2 ln of 4. That sort of eliminates the ambiguity or the confusion around what that term really represents. So really, I like to leave it like this because I actually find that to be less confusing than what I initially wrote back up here. So anyways, now I'm going to continue distributing. Plus 3 natural log of 4 is equal to x natural log of 5. And so just doing a quick inventory here of where all of my terms are, I've got a term that has x here, and I've got a term that has x here. And so I need both of those to be on the same side of the equation. And so what I'm going to do is I'm going to subtract this one that's on the right-hand side over to the left, and then I'm going to move this other term that does not have x. I'm going to move it to the right-hand side and just change its sign. So that one's going to get moved over to that side. So what I'm going to have here is 2x ln of 4 minus x ln of 5 is equal to negative 3 ln of 4. And now what I notice is that both of my terms on the left-hand side have an x in them. And so what that's going to allow me to do is factor out an x, and that will leave me with 2 ln of 4 minus ln of 5 equals to negative 3 ln of 4. And so now to get x by itself, all we're going to have to do is divide by this parentheses. So 2 ln of 4 minus ln of 5 gets divided on both sides of the equation. And so now it's just a calculator contest of being able to put this number over here into your calculator. And if you do that correctly, then to 3 decimal places, you ought to get negative 3.576. Okay, here again on example F, we have exponential expressions on both sides of the equation. And so we're going to have to distribute like we did before. This time we're going to have to distribute on both sides, as you're going to see here in just a second. And then get all of the terms that have x on one side, all of the terms that don't have x on the other side, so that we can factor and divide and eventually solve for x. So let's jump into that process. We're going to start with our first step, which is to take the natural log of both sides. And so I'll have the natural log of 3 to the 2x plus 1 is equal to the natural log of 6 to the x plus 2. And because I've taken the natural log, that now allows me to move those exponents out of the exponent and into the front of the logarithm. And make sure that you put parentheses around them, because it's all going to have to be multiplied by those natural logarithms. Okay, so let's go ahead and distribute on both sides. So I'm going to have 2x natural log of 3 plus the natural log of 3 is equal to x times the natural log of 6 plus 2 times the natural log of 6. And so now, as I said just a second ago, what we want to do is move all of the terms that have x, which would be this one and this one, onto the same side of the equal sign. And so that means that the one on the right-hand side is going to have to be subtracted over. And so I'm going to start by just writing down that first one and then subtracting that other term that has x in it. And then any term that does not have x, so for example, this term right here, that is going to have to move to the other side to be with this other term that also does not have an x in it. And so my right-hand side is going to say negative ln of 3 plus 2 ln of 6. Or you could have written that 2 ln 6 minus ln 3. That would have also worked. Okay, so now on the left-hand side, notice that both terms have an x. And so therefore I'm going to factor out an x, and that's going to leave me with 2 ln of 3 minus natural log of 6. And that's going to equal to, I'm going to go ahead and write that probably the more common way, which is to put the negative term second there. And so now, in order to get x by itself, we're just going to divide by this parentheses here. So 2 natural log of 3 minus the natural log of 6 gets divided on both sides. And so now it is just a calculator contest. I would highly recommend using the fraction button in your calculator. And so if you don't know what that is and you're using a TI-84 calculator, you just hit alpha and then y equals and then enter to get a fraction. And you can just type in what it says right here in order to get your answer. And if you do that to 3 decimal places, what you're going to get is 6.129. Okay, on this last example, before we get to the application problems, this one's a little bit different than the previous questions. This is an exponential equation because I do have variables in the exponents, but this is in what I would call a quadratic form. And so what I mean by that is this looks very similar to, for example, x squared minus 4x plus 3. Because notice, this first term is e to the x, it's just squared. Because you could say, you know, this is e to the x squared, and then minus 4 e to the x plus 3. And so this is exactly the same equation as the quadratic x squared minus 4x plus 3. It's just that x has been replaced with e to the x. And so when we factor this, we're still going to need factors that multiply to 3 and add to negative 4. And so that would be negative 3 and negative 1. And so when we factor this, we're not going to put x minus 3 and x minus 1, but instead we're going to put e to the x minus 3 and e to the x minus 1 is equal to 0. Okay, so now we can set both of these equal to 0. So e to the x minus 3 is equal to 0, and e to the x minus 1 is equal to 0. And so when I do that, I'm just going to add 3 on both sides. So e to the x is equal to 3. And then to get rid of e, I know that I need to take the natural log of both sides. So when I take the natural log of this side, it's going to cancel. So I'm going to get x is equal to the natural log of 3, which is going to be approximately, to 3 decimal places, 1.099. And then for e to the x minus 1, this will just be e to the x equals 1, and then take the natural log of both sides. So x is equal to the natural log of 1, which is 0. So we have two answers here, 1.099 and 0. And again, you're going to see questions like this pop up from time to time that are in this quadratic form. And so be on the lookout for those types of questions.